Ever wondered how OSPF, one of the most widely used protocols in network routing, operates? Today, we're going to delve into the inner workings of the Open Shortest Path First protocol, commonly known as OSPF. This protocol plays a tremendous role in network routing, ensuring data takes the quickest and most efficient route from one network to another. This episode will unfold the advanced OSPF configurations and concepts, taking you a step further into this fascinating world. We'll dissect the intricacies of OSPF, shedding light on advanced topics that make OSPF the powerful protocol it is today. We'll also delve into OSPF Authentication, a vital security measure that prevents unauthorized routers from sending information. Lastly, we'll explore virtual links, an exceptional OSPF feature that allows flexibility in network design and operation. These topics form the backbone of advanced OSPF understanding and application. Ready to dive into the world of OSPF? Let's get started. OSPF configurations aren't as complex as they seem once you understand the underlying concepts. Let's delve into the world of OSPF configurations, a fundamental aspect of network operations. OSPF, or Open Shortest Path First, is a dynamic routing protocol that uses configurations to establish and manage routing information within a network. These configurations are essentially rules or parameters that guide how OSPF functions in a network environment. The journey begins with the creation of adjacency. In the realm of OSPF, routers need to become neighbors first before they can share routing information. This neighborly bond is referred to as adjacency. OSPF uses hello packets to establish this relationship, a bit like a digital handshake between routers. Once adjacency is established, the next step is the exchange of routing information. OSPF routers share their link state database, a record of the network's topology, with their OSPF neighbors. This exchange process ensures that all routers in an OSPF area have a consistent view of the network. Now, with all this information at hand, OSPF routers must decide on the best paths for data packets to traverse the network. This is where the OSPF algorithm comes into play, calculating the shortest path to each network destination. The result of this calculation is the routing table, a map of sorts guiding data packets to their destinations. Each of these steps, from adjacency creation to route selection, are guided by OSPF configurations. The configurations dictate how OSPF behaves, from the frequency of hello packets to the cost associated with each network link. These configurations can be tweaked and adjusted to optimize network performance, allowing network engineers to influence how data travels through their network. It's a bit like being a traffic controller, but for data packets instead of cars. So, that's a high-level overview of OSPF configurations. It's a process of establishing relationships, exchanging information, and making decisions, all guided by a set of rules or configurations. Understanding these configurations is the first step towards mastering OSPF. Now that we have a grasp on OSPF configurations, it's time to explore some of its advanced concepts. Firstly, let's unpack the OSPF database. This is a comprehensive repository of all the routing information that an OSPF router knows. It's like a map detailing the network's topology. Each router maintains its own OSPF database, which is updated dynamically and regularly to ensure all routers have a consistent view of the network. Link state advertisements, or LSAs, are the messengers in this scenario. They carry the information about network links and OSPF routers, traveling from router to router, updating each OSPF database along the way. LSAs are the building blocks of the OSPF database, and they are of several types, each carrying different information about the network. Now let's talk about OSPF areas. An area is a group of contiguous networks and routers. All routers in the same area have the same topological database. Areas are a crucial part of OSPF's scalability. By dividing the network into areas, OSPF reduces the size of the database and minimizes the routing update traffic, making the network more efficient. In an OSPF network, we have an area called the backbone area, also known as Area 0. This is the heart of an OSPF network, and all other areas must connect to it. The backbone area helps in routing between areas, making it an essential part of the OSPF design. Together, the OSPF database, LSAs, and areas form the backbone of the OSPF protocol, making it robust and scalable. They ensure that OSPF can handle large network topologies, minimizing network traffic and maximizing efficiency. As we delve deeper into OSPF, these concepts will become second nature. They are the pillars of understanding how OSPF works under the hood. By understanding these concepts, you'll be able to design and troubleshoot OSPF networks more effectively. Mastering these advanced concepts will take your OSPF knowledge to the next level. Security is paramount in networking, and OSPF, short for Open Shortest Path First, is no exception. Let's dive into the concept of OSPF authentication. This is an essential feature that secures the exchange of routing updates, ensuring that only trusted routers participate in the OSPF process. OSPF authentication is important for two main reasons. First, it prevents unauthorized routers from participating in your OSPF network, potentially disrupting your network operations. Second, it ensures the integrity of the routing information being exchanged, protecting it from being tampered with. So, how does OSPF authentication work? Well, it's all about the exchange of passwords. When two routers want to establish an OSPF relationship, they must exchange a password or key. If the keys match, the relationship is established. If not, the relationship is denied. There are three types of OSPF authentication: Type 0, Type 1, and Type 2. Type 0 is essentially no authentication, which isn't very secure, but may be used in trusted environments. Type 1 is plain text authentication, where the password is sent in clear text. This isn't very secure either, as anyone who intercepts the OSPF packet can read the password. Finally, Type 2 is MD5 authentication, which is the most secure. In this method, the password is hashed using the MD5 algorithm, making it extremely difficult to decipher, even if intercepted. Now let's touch upon the configuration of OSPF authentication. This is done on a per-interface basis in the interface configuration mode. You'll need to specify the OSPF area, the authentication type, and the password. For Type 2 authentication, you'll also need to specify the MD5 key. Remember, OSPF authentication is not a one-size-fits-all solution. The type of authentication you choose will depend on your network's security needs and capabilities. But regardless of the type, implementing OSPF authentication is a critical step in securing your OSPF network. With OSPF authentication, you can ensure the integrity and confidentiality of your routing information. Ever wondered how OSPF handles discontiguous areas? The answer lies in virtual links. Now, let's delve into the world of virtual links in OSPF. To put it simply, virtual links are logical, not physical, connections that establish a pathway between two areas in an OSPF network that are not directly connected. They act as a bridge connecting these separated areas to the OSPF backbone, Area 0. But why are virtual links needed, you may ask? Let's imagine a scenario where an OSPF network has a discontiguous backbone. In such a situation, the OSPF protocol would fail to function properly because it requires all areas to connect directly to the backbone. This is where virtual links come to the rescue. They provide a workaround, ensuring that all areas remain connected to the backbone even when the physical layout of the network doesn't allow for it. Now, let's talk about configuring virtual links. This is done using the Area Virtual Link command in OSPF router configuration mode. This command requires two arguments: the area ID of the transit area and the router ID of the ABR at the far end of the virtual link. The configuration must be identical on both routers that are part of the virtual link. Let's not forget that virtual links are not a permanent solution. They're a temporary fix for network design issues, like discontiguous backbones, or when a new area needs to be added that can't be directly connected to the backbone. In essence, the role of virtual links in OSPF is to ensure connectivity. They help maintain the hierarchical structure of OSPF, which is key to its scalability and efficiency. By creating a logical pathway where a physical one doesn't exist, virtual links allow OSPF to function as intended, keeping all areas connected to the backbone. To sum up, virtual links in OSPF are like the secret passageways in a labyrinth, providing a direct route where there isn't one. They're a testament to the flexibility and robustness of the OSPF protocol. Virtual links are a crucial tool in managing OSPF networks. We've covered a lot of ground in this video, so let's take a moment to recap. We delved deep into advanced OSPF configurations and concepts, exploring the intricacies and complexities that can often be overlooked. From the basic understanding of OSPF, we took a leap into the advanced arena, shedding light on how OSPF operates under the hood. We also discussed OSPF Authentication, a crucial component in achieving network security. This ensures that only authorized devices can participate in the OSPF routing process, a feature that is essential for maintaining a secure and efficient network. Moreover, we explored the concept of virtual links in OSPF, allowing for greater flexibility and stability in our network topology. These links help maintain OSPF area connectivity even in the face of unusual or unexpected network configurations. With these OSPF skills under your belt, you're well on your way to becoming a network routing expert. Stay tuned for more.